Well, hello everyone. This is basically replacing the kind of the cancelled class from today due to the issues I've had. So what I intended to do is to go over this chapter 9, which is the introduction to scatter plots and correlation. We covered the theory on Tuesday, so now I'm just going to show you the types of things that you would be asked in your homework and how we can use SALT to calculate things like the correlation coefficient and so on. So here we have 3 scatter plots. And it says which diagram shows a high linear correlation. Now the key word here is linear. If you look at this shape here, it's quite a smooth set of points, but it clearly is a curve. So that is definitely not a very good single straight line. This one here is a really good straight line. And the dots, the points are very close to each other. And this one is not as good as that one, but at least it's linear. And this one is the worst of the 3. So this guy is going to be moderate. This guy here is going to be, see our choices are high. Oops, no one. Let's see, I should say. B is going to be no, definitely not linear. And then we can go and do the last one, which would be high. We have to check it. There we go. Now here's 3 more. And it's the same thing. You're going to be looking at how good a fit the data is to a single straight line. I think it's pretty obvious which one of those 3 is going to be the low one, right? Or no correlation. Actually, it would be that one. And which one of these 2 would be the good one, and which one of them would be the weaker. And after that, they move on to questions where they talk about, let's read this one. Over the past few years, there has been a strong positive correlation. So along the x-axis, you would plot the annual consumption of diet soda. So you can imagine how many cans of diet soda were drank in a year. And vertical traffic accidents. So the first one was how much data, diet soda. So that would be your x. The explanatory variable is your x. And the response variable would be the number of accidents. And they're telling us basically that it's a strong positive correlation, which means the more diet soda that is drank, the more traffic accidents are there. Well, let's assume that that information is actually telling the truth. It says, do you think increasing consumption of diet soda is causing the increase in traffic accidents? Now, I'm pretty sure that they're not. And they're not. Now, you might say, well, what is the lurking variable here? Well, could be lots of other explanations. There's a few. Couldn't it simply be that as every year goes by, there are more people driving, and more people driving essentially leads to more accidents. So all you're really doing is measuring time against the number of accidents, and time itself is measuring the population of America. So if the population of America, let's say, increases by 2 million a year, and half of them are able to and do drive cars, can you see you're going to have 1 million more people on the road every year? And even if they're just as safe as everybody else, that's going to increase the number of accidents. So that's one explanation, not the only one. And here's another one, which you can read through on your own. And here's the third one. So you're going to be looking at that phrase, which is a big one, big one. And that is that correlation does not mean necessarily causation. So just because you've got data that is nice and close and maybe it's positive, right? So the x-axis gets bigger, the y-axis values also get bigger. That, or the alternative to that, doesn't mean that the x is causing the y. Now, let X be the average number of employees in the group health insurance plan, and Y be the average administrative cost as a percentage of claims. So if there were 34 people in this factory company, and that's the average amount that they spend in a serious claim. Here you've got that, and it's asking us to create a scatter plot. Now you could simply do that. There is only 5 points. When you do X going from 0 to just after 70, and the Y values would probably be what, height of 40 down to 17, and if you can imagine plotting 3,40, 7,35, and so on, you would get one of these pictures. I actually suggest that you do that by hand, because I'm about to hit, this might not work, so I'm kind of thinking, use the sort button. Now, I'm not worried about the fact I'm using the sort button. What I'm kind of more worried about is scale is everything in these questions. So if you change the X-axis scale or the Y-axis scale, you certainly can make the data look different. But let's show you how you would plot all these points on a scatter plot. You'd hit charts and graphs, and then you would do, what is it? Gotcha, scatter plot. And the X-axis, average number of employees in the company, Y-axis, the average cost of an insurance claim. I'm going to try and shrink this back a bit because it's such a big picture. Yeah. Now, do you see the data has a kind of, it's going downwards, so it's definitely negative. So what you then have to do, this is where the hard part is, you then have to figure out which one of the graphs that we had does that one compare against. Now the hard part for me, there we go. Now, from what I recollect seeing, the answer is one of these two here. I would probably want to double check by maybe picking a point and just checking against it. So for instance, 7117. Right, if I look at that, that's 7117. And if I look at the one next door to it, that's pretty much the same. Oh, there we go. This one's the one I'm picking. 3,40 would be about here. 3,40 doesn't exist on this one. So that would be my choice. So I would probably just get some, scratch paper, square paper would be better. Pick a decent scale, plot them and see how things go. Now, if we assume that this is the scatter plot that they had, or something like that, would you say that the correlation is low, moderate, or strong, and positive and negative? Well, two different things. It's going downhill, right? So that's negative. And I'm looking at that and I'm going to go, and it's a bit of a judgment call, so I'm going to go moderate and negative. And now I'm just going to hit submit answer because I want to see if I got that correct. And yes, I got the picture correct. And moderate and negative didn't work. So I'm going to go for low and negative and submit answer. I'm a little bit confused. So the only one is strong. Let's see that one. And I'm definitely going to argue about this one. When you look at this data, does that look very straight to you? To me, it doesn't look particularly straight. And so I'm assuming that we're talking about linear correlation. But at least we agree on the negative. There is some justification for them calling it strong, but it's not a very good justification. Can you imagine if you've only got a few points, like 3, 4, 5, 6 points? There's not going to be an awful lot of variation. I'll give you an example. If I get 2 points, a scatter plot with only 2 points, aren't I guaranteed a perfect straight line? Just join the two together. But if you add another point, a third point, can you imagine as long as it's not too far away from the other two, you're going to get a line that's pretty close to all three. So I suspect that's what's happening here. Now, it then says this bit, which it says in a lot of questions, and we really don't want to get too caught up on this. It says, use your calculator to verify that this sigma x is that number, that sigma x squared is this number, sigma y, and so on. And these guys here are used, if you were going to do it by hand, with some other things that you have to add to it, to compute the correlation coefficient R. So really what you want to do here is figure out what R is. And the bit about use your calculator to verify, I would not do that. It's a lot of extra work, and you're really not going to get much out of it. So let's show you how you get R value. I'll hit this level. Got my data. I'm doing its thing. I'm going to hit regression. I'm going to pick this guy for X, pick that guy for Y. I'm even going to hit regression lines so you can see, oh, that helps, actually. Still wouldn't call it strong. Right down here, somewhere, I'll look hard enough, I should find R. And there it is. It should be called correlation coefficient in R, but they're just calling it correlation. It's lazy. That's your number. And if you look at that, that number is actually quite close to -1. So I was a bit unfair with them when I went and said that doesn't look strong. The correlation -0.96. Would you agree that's darn close to -1? That is an example of strong. So you would take this guy and you would put in your answer there. Now, did you notice that I didn't actually check that all these calculations are correct? And I suggest that we don't. We can basically just turn this question into find the correlation coefficient R. And it's going to be called correlation in SOLVE. So you have to kind of look to that. Now, since this is a very close to -1, that means it's going down, right? So this little sentence here says, as X increases, does the value of R imply that Y should tend to increase or decrease? Oh well, as X gets bigger, the Y is going downhill, so it should decrease. So Y should tend to decrease as X increases. Let's do a submit on those two. You already know we got this right. I've changed my mind and decided that that strong is actually valid. Can you see the correlation coefficient and this guy? That's pretty much a standard type of question that you're going to get. Right? You're going to have some information that becomes a scatter plot. You're then going to look at it and tell me maybe it's positive, maybe it's negative, maybe it's strong or moderate or weak. You're then going to calculate the correlation coefficient. Actually, I think it would be better if you calculated that before you answer B, because that would make it a little bit easier to decide. If R is a decent number, very close to -1, then that is an indication that as X axis, as X gets bigger, the Y goes downhill, so the Y should decrease. If R is a very close to 1, like a 0.99 kind of thing, then as X increases, the Y would also increase. That is it. So our next one is about can a low barometer reading be used to predict the maximum wind speed of an approaching tropical cyclone? So you can imagine that people that are into, predicting what the weather is going to be like, and they know there's a cyclone out there coming in. One of the indicators before it hits could be, what's it called again? The lowest pressure, right? The pressure that you get in one of those barometers. So you've got a barometer and you say, oh, it's 980. I wonder what kind of maximum speed you're going to get when that cyclone finally hits this tropical cyclone. So for instance, when the barometer was just over 1,000 it was a 40 mile an hour, which is okay, but it's not horrible, right? And if you look at the lowest one, when the barometer reached 920, God, that's bad. 152, that's knocking down trees, houses, who knows what, that's bad. Now, the first part of the question, just like normal, make a scatter one. If you do it in paper, one of these pictures will look good. I'm just looking at the rough data here. Can you see that for big X's, the value of Y is small, and for small X's, the value of Y goes bigger? So if you imagine your X-axis, as the X's increases, doesn't the Y value go down? In other words, from 800 to 900 to 1,000, doesn't the wind speed go from 150 to 100 to 40? It's going down. So I'm pretty sure that it's either this picture here or this one be here, right? So if I take a point like 1,004, which is about here, and that's about 40, that's about, oh, they switched the axes on me. So guess what? I got that one for free. Now, would you consider the correlation as low, moderate, or strong? Well, since I got the last one wrong, I'm looking at that with my eyes and I'm thinking that's probably going to be a pretty decent line because there's not a lot of points and it doesn't seem to have too much going on with it. So I'm going to go for strong. Is it positive or negative? No argument. Downhill is negative. Calculate the guys? No, we won't, but will we compute R? Yes, we will. At this point here, salt should take over. And where is my salt button? Oh, Darwin's. Okay. I'm taking a note of the X values and the corresponding Y values. And we are going to use salt, even though it's not there, which is really annoying, to calculate R. So if you kind of bear with me while I take a copy of these, kind of what you would have to do. And I'm just going to go, I'm going to use any salt button I can find. And I am going to type in my data. So I'm going to go here, and I'm going to do 1,004. And 5. Oh, got that one there. Then I'm going to go to the second point, and it's going to be 975, 100. So I'm basically just stealing the salt question and putting in my own data. 992.65. You can actually go online and read their ebook, and it'll tell you how you could do this calculation by hand. And I think once you've seen what that calculation looks like, you'll probably end up doing what I'm doing right now. And that is letting salt do it for me. And I'm almost done. This number here is 979, and the wind speed when that was the barometer pressure was 84. I'll accept that one. Since I need to add one more row, I'm just going to do it. I'm going to put in here 920, and the last one is going to be 152. So what I've done here is I've changed the data to the guys that I need. And then I can go and I can do all sorts of things. But the thing I want to do is get R. So I do that. Select X, select Y. Forget about what the names are. Put in my little regression line. And then find R. That's that number. And go down here. Put in the value of R. So as X increases, because this is a negative correlation rate, the line is going downwards. As the x's increase, the y values decrease. So I'm just trying to find the one that says that. So y should tend to decrease as x increases. And let's do a submit. And fingers crossed I didn't type one of the data points wrongly. Got my picture, and bingo. So you're going to have to adapt some of these questions when it asks you to compute, to calculate the value of R. And if you don't like doing these questions without a sort button, hopefully that's the only one that doesn't have a sort button, then you would need to look it up and find out the horrible calculation, which I'm not even going to show you because I don't think it's worthwhile. Well, in this one here, here's your data. Pick a scatter plot, find your R, and then answer the question. You see, it's basically the same connections. Let's see what this story is. The magnitude of an earthquake, which is the x's, these magnitudes, is related to the depth below the surface at which it occurs. Let x be the magnitude of the earthquake. That's these guys. And let y be the depth. So there was an earthquake, magnitude 3.2, and its epicenter where it started was 5 miles under the surface. We have 1, 2, 3, 4 pictures to look at. And I'm going to go straight into use of salt. And I'm going to find R first. Because when I do that, I get my picture for free. Magnitude, depth. And I might shrink this a little bit so you can see it. And there's my regression line. Right, when you look at this data, can you see that the points are all over this? Now, you have to be a little bit careful about scale, because they've actually shrunk the y-axis scale. But if you made it full, it would probably, these points would go a little bit closer. But based on what I can see, the correlation coefficient is down here, and it's positive 0.4049. I didn't copy that, but I can remember where it was. 4049. That's a positive number. If I remember the picture, I think it looked closer to that one. That's what I believe the picture looked like. And it's positive, and basically then, when x gets bigger, so does y increase. So I'm looking for y should increase as x increases. And then I'll just submit the answer and that was right. And then the next story is about baseball. The next story is about, do larger universities have more property crime? I think that makes sense that they should. Bigger universities have more things for people to steal, steal. So it would surprise me if it was more, unless they standardized it. They have 100 students kind of thing. And that's pretty much it. So all I'm doing today, all I wanted to cover was the chapter 9 scatter plots and correlation, and how you can use SALT to sketch scatter plots, to find R, and then the simple sentence you're going to do is, okay, as x increases, what does y do? Now, the last section that we're going to do, which we'll see on Thursday, fingers crossed, technology will be our friend and I'll be able to be with you, is take this just a little bit further. And what that's going to be is, okay, let's pretend I've got a scatter plot and it looks like this. And we know that there's a straight line because it's linear. Wouldn't it be helpful if we could find the equation of that best fitting line? So we're going to do that. We're also going to say, okay, once you've found this best fitting line, which, by the way, SALT will do it for you, You can then use it to predict things. So if I have an equation of a line that goes through this data, I can then say if you're 30, the average value for y would be this. And we can use it to predict things. But that's for another day. So that's me. Bye bye, and I shall see you tomorrow.